Hi guys, welcome back to my channel. In this video, I'm going to discuss about the neumann architecture, one Neumann architecture, and I have discussed the information of the architecture and the two basic things, that is one Neumann architecture and other is hardware architecture in the previous video. If you have not yet watched, please check in my series of videos and please watch it. And in this monument architecture, let's see how the architecture is designed, and for that there are few instructions in the one human architecture. The first thing is there will be only single shared memory, so let's first draw that single shared memory, and there will be two bus lines. So let me write it here first. What is this? Is memory. This is memory, and there will be two bus lines in it. Let's see what the other part is, and the other part is of CPU. CPU. Let me draw the CPU too. CPU. This is the central processing unit, CPU, and in CPU will be having different things, and the other is in the CPU we'll be having other unit of box. Well, 1 minute, we'll be having other unit of box, that is DPU, called as DPU. Let's see what is DPU and what the thing will be done by DPU in detail. First let me draw it. So this is DPU, and in DPU we'll be having we'll be having the other part, that is ALU. ALU. I hope you guys all know that what is meant by ALU. Though we'll see what ALU means. And the other block in the CPU is PCU. I hope you all also know this PCU, though we'll discuss it. What is meant by PCU, DLU and ALU. So we all know that, we all know that. Okay, let me explain before going in detail to the VNAM architecture, how I drew this memory block and CPU, so that we have to know the first thing, that is digital computers. Okay, let me draw it first. This is CPU and this is RAM. Okay, and okay, let me label these. This is input. This is output, and this is IOP, that is input output processor, and this is CPU, and this is RAM. Okay, I hope it is not clear, but okay, hope you will understand. This is the RAM, which is random access memory. Let me draw with pencil. Okay, we'll be giving input. We'll be giving input through this is input devices. We'll be giving input through input devices through to the input output processors, and this input output processor will send the information what we have given to the CPU, that is central processing unit. And this central processing unit will be consisting the resistors, and this resistors will send the information to the random access memory, which will be the RAM will be storing the information in the binary format, and that will be sent, the information will be retrieved here. That is, as I have explained the digital computer block diagram in previous videos in detail. Please go and watch it if you have not yet watched. And that information will, which is retrieved by RAM, will send to the CPU again, and that information will be sent to the input output processor. The input output processor will translate again into the high level language, and it sends to the output devices like the monitors. Okay, this is the process done by the digital computers. Okay, block diagram of digital computer. And this is VNAM architecture. VNAM architecture is something that happens between the CPU and the random access memory. Okay, that is this memory and CPU. So the things what happen in between these two is will be discussed in this architecture, VNAM architecture. In the VNAM architecture, the first condition is having the single shared memory. So there is only one memory here, that is known as single shared memory. And the second thing is there will be two bus lines. What is meant by bus is, if, as of now, let's see the normal definition of bus, which sends and gets the information uh, through the bus, that is in the both the directions. So from the memory unit, the data, okay, two bus lines are there in this VNAM architecture. First one is data bus. Let me write in shortcut DB, which is data bus. And the second thing is address bus, AB, address bus. Okay, the memory and DPU will be having the address bus, sorry, data bus, DB. Let me write in short form, DB, which is nothing but data bus. And this data bus, so that you might have understood what is DPU means. DPU means that data processing unit. Data processing unit. And the second bus is the address bus. Address bus is between the memory and PCU. This is address bus. Okay, and the instructions and program bus also will be there. Let me discuss in detail why this is the extra bus. I'll be saying you. This is instruction bus. Okay, instruction bus. Okay, so what happens in this one neumann architecture? Let's see. Okay, and try to understand this something architecture which happens in between the random access memory and CPU. So we are drawing it first, random access memory and CPU. We have already know that in random access memory there will be clock pulses that have to be sent to the CPU, so that CPU should have some clock. So here we have to write the clock pulses, clock, CLOC, clock. And that is clock. Okay, try to understand. I'm sorry, I couldn't able to write with mouse. So the clock will be given, and here we are giving input true input devices, and we are not mentioning the input devices here. The input device is getting into the CPU and coming out from CPU. Okay, so we have to draw that the coming information, that is input, and coming out is output. Yes, and let's see now in detail. We have drawn the diagram. What happens in this we shall discuss. First, when we given the input to the CPU will send it to the data processing unit. This is data processing unit. Let me change the color. Data processing unit. What data processing unit does is it will process the data. Bulk of data what we are giving through the input will be processed by the data processing unit, and the register set stores intermediate data used during the execution of instructions. Will be giving the intermediate data, so that will be set by the data it will process the information what we set. And what does ALU do? There will be minute things that have to be performed. The ALU is the arithmetic logic unit. Arithmetic logic unit which will perform the minute operations in the data what we have given through the input, that will be performed by the ALU, and that will be in the data processing unit. It is a part of the ALU is a part of data processing unit which makes the data clear. Okay, and it will be sent to the memory unit through the data bus. Okay, that is like suppose I want something. I want like some example. I want my Aadhaar card. So I am giving the input my Aadhaar card into the CPU. I have stored my Aadhaar card with the file name my Aadhaar. So I gave it input my Aadhaar. So the data will be processed, and if there is some arithmetic logic operation that have to be performed, the ALU will be performed it. And that information, if no arithmetic operations, then no arithmetic operations will be done. This information will be sent to the RAM or the memory. Okay, will be sent to the memory, and that will be processed, that will be searched in the memory unit, and that will be retrieved back to the data processing units, because it cannot directly random access memory cannot directly give you the output. So it have to give it to the let me use another color. Let me use green. It have to give it to the CPU. It cannot directly give the output, so the bus line should be used so that it should come back. Okay, the memory and data bus is done. Now address bus. What address bus will be doing? The PCU is nothing but program control unit. This is control unit. Transfers information among the registers and control constructions the arithmetic logic unit which operates to perform. So what arithmetic logic operations done will be linked to the program control unit also. So how these will be connected? How there is here in the diagram, there is no connection between the arithmetic logic unit and program logic unit, but there is something we have to draw. I have to explain about this, so I haven't drawn the previous while drawing it. There will be two things that happen between the arithmetic logic unit and program control unit. What is that is, from arithmetical logic unit, the information will be sent to the program control unit, that is known as status. Let me try it. let me write once again. Status. Okay. And okay, let me draw it in detail. This will be sent from arithmetic logic unit to the program control unit. The status will be sent. What operations have done in arithmetic logic unit will be sent to the program control unit through the status provider, and this PCU will send back the controlling part. Suppose there are 5 instructions I have given. The arithmetic logic unit has performed it and send the status to the PCU. Now PCU have to control it up to what statements first it have to be performed. Suppose I have given 5 statements. The PCU control the arithmetic logic unit, deals it and sends it to the program control unit, and now program control unit have to control it and send back to the arithmetic logic unit up to 3 statements I want. It will send it to the ALU. That sending process and that happens between PCU and ALU. PCU to ALU, that is control. It controls that how many statements it requires, right? It controls how many statements does the PCU want. It controls that 3 statements I want. The arithmetic logic unit will send it to the DPU. Now data processing unit will send it to the memory block that I want 3 statements, 3 files or 3 statements in the files. The data processing will be sent to the memory block. Thus the information will be retrieved. And the program control unit also has the separate bus. This is address bus. Directly this deals with the address of the file that we want, and there will be also an instruction bus, that is what the instructions that we are giving through the input. And this is one way we have seen that CPU to memory block. Now the information will be processed in memory block. Information will be processed in the memory block and send back every bus line to back to CPU. That is, bus is nothing but having 2 flow, having this and this, which is nothing but bus line is nothing but this plus this. That is having 2 flows, is known as bus. We have seen from CPU to memory. Now what happens in the memory? Data bus will be searched, data bus will be getting into the memory and data will be searched and giving back to the CPU, and it is this part, giving back to the CPU, and the address bus will be coming into the memory block, and the information will be retrieved and coming back to the PCU, and that is the second part. Thus the data we want from memory unit will be given back to the CPU, and CPU will perform it and gives back to the output devices in this way. This is von Neumann architecture. In the next video, we shall discuss about the other architecture, that is hardware architecture. Thank you.